Hi, good evening, everyone. So, welcome to the 10th week open session. So, week 10 is also in the syllabus of the OPP exam. So, and there's no quiz too for this C programming. Okay, so I hope, but you may have the other course for the quiz too. So, you maybe preparing for the quiz too also. But definitely, question may be asked in the OPP2 exam for the week 10. So this is week 10 is basically file handling and bit manipulation. These are the two main topics for the week. But this is also very important for the NTERM exam. Okay, so NTERM exam syllabus will be basically from the week 3 to week 11. Okay, all the coding that means C programming related part, that will be the syllabus for the NTERM exam. Okay, so I'm starting week 10 summary. And before that, if anyone have any query, you can also ask. Okay. Any query from anyone? Okay, Siva Kumar, sir. Okay, fine. If no query, let me just go through the content. So, okay, so this is the applet. Yeah. So week 10 file handling, and as every programming language, so this is the main important topics when we want to access the file actually, okay, and from our program. So we want to read the content from the file, which is actually stored in our hard disk or any that permanent storage place, and we want to just access the content, and we want to also perform some that write operation or edit operation on that. So how we can do with the help of this programming language? So C also provide this some functions. With the help of these functions, we can manipulate the file. Okay, for the reading, writing. Okay, these purpose. So we will understand that how we can update this, and what are the function actually C provided. So first thing, the purpose of the file handling is just a store data that persistently means permanently. We want to store our data and we want to save the file, okay, in some permanent storage place. And once our program terminated, still our data will be remain exist. So most of the time, till now, what we are doing actually, we are get reading some data from the user and performing some operation, and then we are returning some output. But that happens only the during the running time when our program is running, that is taking the data. But there is no permanent storage we have during that time. But now we'll understand the file. So these are the things: store data permanently, basically, or read existing data from any file. So these are the basic operations we will cover. So basic file operations. So that means when we are just performing some operation on the file. So what are the things we require, and what are the steps required? So this is the first thing. Include header. Okay, so that means we will use some specific file pointer here. Okay, so you can see there is a one file pointer, so that will actually just contain the reference file content. Okay, so this is just a internally things that it maintains some structure, and that structure maintains some pointers or things, so that for the file and buffering, and there are multiple process actually involved during this real file handling during the program, with the help of program. So but we only use this file pointer. Okay, so this file pointer actually we will use this file pointer to read the data and also write the data, so that will contain that some reference pointer to some place of the file. Okay, so to use this file pointer, we need a header file, because the all definitions of this file pointer is defined inside this file stdio.h. Okay, so because this is also an input output type of operation, so because of that, this also included in the standard input output library. So this header file is required for this function. And then if you want to access any file, so we have to declare one pointer first. Okay, this is very similar to your that another variables which we are using. Only the data type is we will use as a file in the capital L E. Okay, and otherwise we will give some name, and that pointer will remain same as the normal pointer. Then open the file. Okay, so this is the declare one file pointer, and then open the file. So this there is one command to open. Okay, so open that this is the function to open the file. Open function stabilize a connection between your program and the file. So this actually will connect your program to your the, and some parameters are required for this function. So that is actually a first file name. Okay, so that file name should be in okay, so it's string file name, and just you can represent with the double quote, and also mode. Okay, so which mode actually you want to open the, what operation, what type of operation you want to work. Okay, so a string specify how the file will be opened. Common modes include, these are the very common mode we generally use to open any file. So first is R. Okay, so I'll just give you a demonstration for that, but just keep this thing in mind. This is also important for the enter exam purpose. So R mode, simple R character. Okay, so this represent a read mode. Okay, open the file for reading purpose only. Okay, existing file. So if file is exist, then it will open that file in the read mode, and you can read the content. Then W, this is the another mode. Open the write, open for writing. Okay. So if we want to perform some write operation on the file, then we will open our file in the W mode. If our file is already exist, then it will overwrite that file. Okay. Suppose if we are performing some writing operation on the one file, and we are opening that in the write mode, and the same name file is already exist in our system, then it what will do, it will, our content will be overwrite for that. Okay, otherwise if file not exist, then it will create a new file. Okay, what name we are providing here. So you, the file name is the first parameter. So what file name we are providing here, with the name of that file will be created. Another is A mode. So A means append. Okay, so open pending mode. So this is also a write type mode, but actually it will not overwrite. It will just append the data from the existing to the existing file at the end. Okay, the previous data will also remain as it is. The new data will be append in the end. So this is three normal mode we have. Some modification version is also there. Some advanced version is also there. So that is R plus. So if we want to open the file for both purpose, suppose reading and writing. Okay, so existing file we can open in the R plus purpose, but only existing file. W plus open for both reading and writing. Okay, so see, this is also the same purpose, but it will create a new file. Okay, if file it not exist. A plus mode open for reading and appending. So this is also including reading is also in this. So this is the advanced version of append. So these are some modification of the mode. So just keep this in your mind and regularly use these. So you will also just you can remember easily the purpose of that. And then after that, just look the example here. So how we can actually write a program for that. So this is the structure of file handling program. So first thing, same header file, then main function, and this is a return thing. So this is the main part. Okay, this is the main part of the program. First thing, we are declaring the file pointer here. Okay, so that is file is the data name, data type, and that asterisk fptr. So you can give any name for this. So this is just a point variable name. Okay, this is a pointer. The type of this pointer is file. So you can give any name for this. So asterisk fptr. Now we are just using this fptr equal to fopen. So this is the main line to opening the file. Fopen and bracket, just provide the data dot txt. This is the file name as a first parameter. Second parameter is a mode, w, r plus, or what discuss now. After that, this actually function provide a some pointer address. Okay, so where actually our pointer is point. Okay, so if suppose if file is if any error is coming, or maybe our file is not exist and we are opening in the reading mode, in that case this function will return a null. Okay, if suppose if our program is not able to access the file in because reason, so in that case this function will return null to the pointer. So we will validate this to just make our program that our program should not go into the crash mode. So we are just looking here. If fptr this pointer is equal to null, we are simply just validating this. If our pointer value is equal to null, that means our file is not actually print. So we are just printing this message and stopping our program with this one code. Okay, return one. So this is just a validation purpose. So this is a good practice. Just use this validation before performing some any operation on the file pointer. Then you can perform your file operation like reading, writing, anything. Okay, and then close the file. So this is also very important things, because when we open the file, actually all the resource are acquired by the our program. So file is actually just physical data, so that our hard disk permanent storage, so that resource actually are actually provided to our program, so that access control is also our program have control of that file. So once our task is completed, so close this. Okay, f close fp. Okay, so that means all resource which is now controlled by our program, so that is actually will be freed. Okay, so all memory, some buffer memory will be acquired by our program for the to storing the data of file. So all that actually will be freed, and our will be closed, and another program can access that file and update, perform some work on that. So this closing the file is also very important operation in file handling. Okay, so opening the file and closing the file. So do not miss this. If you are performing any file handling operation, once your task close the file. Okay, with just pass the file pointer inside this operation f close fptr. Okay, so this is the structure. Just maintain this when you want to perform your operation. So just file pointer declaration and open the file, validation that your file is opened properly or not, and then perform your task with the file data. Okay, and then close the file. So this is the structure we follow for the proper working. So now next thing is so this some basic operations. So this is these are the main two operations: writing to a file and reading to a file. So let me check so all joined or not. Any request is there? No. Okay. Okay, writing to a file. So now writing to a file. Uh, Now we want to write some, so we can use some there are multiple operations to perform this task. So I'm just discussing this f printf. This is the one operation. This is very similar to your printf. Okay, so printf is perform the print the output in your output console. Or now printf is means print the output in your file. Okay, so both are very similar in the just in the syntax form. Okay, so we can use this fprintf function to write the data into our file. So how we will use this? So this is also called as a formatted of data. Okay, so we can print or we can write formatted data, formatted data. So that means we can also pass the variable data into the string. So that is the meaning of formatted data here. So let's see the example here. So this is simple main function. We are opening our file. So we are assuming that no, we are opening this file into the data that write mode. Okay. So if file is not there, this will be created. And then we are validating this if our file is all properly opened or not. Then you can see this fprintf, two times we are printing the data into the file. Okay, so you can see fprintf, fptr. So this is text. So this is completely one string. Okay, just pass the file pointer and comma data. Okay, if you have only one string, you can just pass the string, and after that you can leave the optional parameter. So optional parameter is just nothing but that any variable if you want to pass. So next line you can see this is the pointer name. So this is the required things for file pointer, then your string, and at the string you can pass any data for this specifier, okay, from the variable. So here 1 2 3 is written. Otherwise, if you have any variable like ABC, so you can just pass that variable a, and the data for that a will be replaced by this percentile d. Okay, so in that way you can take multiple variable here separated by comma and use the specifier. So this is simple, very simple printf statement where you print the value of some variables in the code. So same things we can do here. Okay, so now this is the first program. Let's see and run this. And okay, just the task. Okay, so we have this main program. So let's run the basic first program. Okay, so now main function, and we have this return 0. Okay, so now we will open the file. So first thing is the file listen. Okay, so let me take file, and I'm taking fptr. So this is the file declare. Now open the file. Okay, so we will just read the take the address in this pointer. So fptr equal to open. Okay, so f open, and inside this let's take the file name data.txt, and we are opening this in the double, sorry, single character. So that is w. We have to use double quote. Okay. So now this is the syntax for the opening the file. So now if file is not exists, so this we create, and then we will validate this. So that means we are checking if that fptr if equal to null. Then we are just printing this. We can print the message like file is not open. Okay, and then return, we can our code like with some error code. So this is our validation task. Now then we want to write some data into the file. Okay, so let's use this that function. So fprintf, and this time variable will be the file pointer. So fptr and then string, and string we can pass here. So this is the like first line to print, okay, in file. Okay, so and we can use this slash n operator to just move the cursor to the next line if you have the one more string to print. So that we can just write this. So fprintf and same fptr, and then we can also pass the variable names. So that variable names, let me, this is the, suppose if I write here it's like percentile d, and then again like print in the file. Okay, and I'm just I'm taking here line number, some variable. So and we can just any variable name like here. So int line number equal to 2. Okay, so now this we have done. And then once our purpose is done, we have written some data in the file, then we will close this file. So close, and this is simply fptr. Okay, so let's run this and see the work. So you can see on the left side menu, you can one file is created. Okay, so data.txt. Okay, and just open this file. You can see both line is now coming in this file. So this is the first line. This is as it is string we have done. This is the formatted version. So where we pass the one variable name and that value is replaced here as is two by the two second line. So this is the way to rewrite something, uh, some formatted data into the file, and we can do this with the help of fprintf. Okay. So I hope this code is clear. Any query in this? Anyone? Any doubt? So you can ask me. Okay. So now let's do the one thing. Let's this little bit and see what happened if I run this code next time. So say like second, this time I'm writing here three. Okay. Okay. So I'm running again this code because in the last time we have seen that our file is created, but what happened this time? Okay, so you can think no new file is created because we are providing the same name. So now the our data will be actually replaced. Okay, first let me see it is not run. Okay, okay. So this is yeah, data is now changed. So second and third. Okay, so you can see data is now overwrite. Let's just do the append mode A. Okay, and write a one more line like this is the fourth, and suppose this is five. Okay, so append mode we can see if I run this same thing, no new file getting, and now you can see data is appended. Okay, so previous data is already there, but you can see this is appended as it is. So let's change slash n operator. Now it will append one more time. Okay, so okay, this was the previous one. Yeah, so this is added. So let's remove this. If suppose if I remove this and then again run, still one is not running. Hmm. So now two times now. Okay, so you can see this in this way data is appending, not just replace removing the data. So we can use this mode for the appending purpose. Okay, so this is the one thing. Let's do the another thing. Next thing is the reading. Okay, so this is now writing. Okay, so once we have the data in the file, we can also write the data. So reading from a file. This is the next thing, next main purpose. To read data from a file, open file, okay, we will use this R. Okay, R mode or sometimes R plus also because we can also do the write operation with the help of this R plus. So you can use scanf. Okay, reading from a file. So this is just similar to your reading the data from user. So that we use the scanf, and reading from file, so that f scanf. Okay, so it is similar to your scanf but reads from a file pointer. So we will read the data from file and we will store the data into our file. So this actually this fscanf is used when we are reading some very types information. Okay, so suppose in our file, we our data is contained in the form of like first value is representing that variable information, second value is representing another variable information that we want to store in our variable directly from file. So as you have already done many programs, so where we read the data from user and we store that data into our variables. Okay, here we will read the same data from the file and we will store in our variable. So in this way, you can see. So this is fscanf. Okay, so this is fscanf. Here will here from we will store read the data. So fptr, this is a pointer where from we will read the data. Format string. So this is just a okay. So we will mention the specifier. Okay, so what type of data we want to read from the file. So what type of value? First value is representing the file. After a space, what is the second value is representing? So suppose file contain like this 10 and then some string, then 20, then something like this. So for this, we will just read this data as a integer, another as a like a set of characters. Okay, and so to understand this, and based on our information, we will mention our specifier here. Okay, so what type of data we are reading actually from the file, and corresponding we will store that data into our variables. So if we have two data coming in the each line, so we will store that data in our two variables. Mention variable here. So now you can see this is the code to so here we have taken the pointer first because here our we are assuming that we are reading some string, okay, from the file. So to store the string we need a array, that character array. Okay, so we are just taking that max 100 to store that, and one variable int num. Okay, and then after that this is the variable which where we want to store the data after reading the file, and we are opening our file in read mode and then validating that, and after that we are reading the data. Okay, so this is the reading and reading here. So data, we are assuming that first value in the line is actually representing string. After space, next value is just like a one integer value. So that value corresponding after reading from the file, it will be stored in the variable. Okay, str and num. Str is an array. Because of that we are not using this n percentile because this itself a pointer. So, and now we are printing the variable data to validate. So this thing we can validate in our code. So in the same thing, let's we are writing here. We are just updating this data. And first value I am just using like 100 name, and next is okay, Ravi. Okay. So this is our file, and then I want to read this and we want to store this. Okay, suppose the first information is id and second is name. So I'll create the variable for that, like int id and care name 100. Okay, and after that we will open this in the write mode, sorry, read mode, validating this file, and then we'll use it fscan fscan. So this is the first thing, f scanf. So first parameter is pointer name, second is just is formatted strings. We will mention the specifier here. So percentile d is the first value and percentile s is the second. Okay, and similarly we will pass the variable name to store. So that first is id, so we will use and symbol for id, and next is just a name. Okay, so to validate this, we will print the variable value now. So that f print, so not yeah, print f simply percentile d space and percentile s, and pass the value id comma name. run this. File is same. Okay. So you can see. So our program is actually reading the data from file. Okay. And that data is now printing in the output console by this second line. Okay, so we are opening the file. So first value is now is printed ID by this. Okay, %ld. Second is printed by name. Ravi. So many of the program in the coming time you will see in the, suppose if you are running some competitive platforms, so that competitive platforms actually provide the input in the file form, and they actually provide the setup to read the data, all these things from the file, because they provide very big input, so that cannot be provided on output console. So generally that output is input is provided from the file. So that data is actually read like this, okay, from the file, and now after storing into the variable, you can perform your task, okay, because now you got the data in your input variable, and then you can perform any task on that. So this is basic two operation: input and output operation on the file, reading and writing. Okay. So now next operation we have already discussed. So this closing is part is required. So that just close the file once your task is done. After that, we have some another way. So we have already discussed this fscanf. Okay. So how we can use this fscanf. Another function is also there, fgetc or fgets. So there are some limitation for each function, and some advantage of the another function. We will one by one. So fscanf, what we have just understand here. So fscanf is used to read formatted data from the file. Okay, so formatted means some specific value data for some we want to use in our variable. Then we can directly read with the help of this. It allowed to read data from your file using a formatted string, similar to your scanf. So this is the function code. We have already discussed this thing. Here fp. Okay, so this is all about the information. So in this type of data, we can you read with the help of fscanf. But what about the fgetc? Okay, so fgetc is actually used to read a character, single character from the at a time. Okay, so this fgetc is actually will read only single character from the file. It takes a file pointer as an argument. It returns the next character from the file as an integer or eof. Okay, so this function will read one character. If you want to read complete data content from the file, so we have to run this fgetc multiple times. Each time it will return a one character. Okay, and pointer will be moved to the next character. So one by one we can move this fgetc and multiple times, and we can read the complete data content. So this is the only function we need to require to write in our code, fgetc, and this will return only single character to our variable. Okay, so but we have to run multiple times this function to read each character. So how we can use this? So let's use the same code. So I'm writing, suppose hello world. Okay, suppose this is the data. Now we want to read this. So so now our file is already open. Character we can take, suppose single character I'm taking, ch, and this is location, and now okay here. So if I just write a ch equal to fgetc and pass the pointer fptr. Okay, this, and just print this what you are getting in the ch. So that is uh, percentile c, because this is a character. So and we are printing this ch. Okay, comma is missing. Okay, so let's run this and see what we are getting. Okay, see only first character we are getting, H. Okay. Now, if suppose if I run this one more time, the same part, okay. So what will be the next character? You can see HE. So that means first time when we call this function, first character is returned, but the pointer is moved to the next character because already one character is returned by this function. So pointer is moved to the next character, and next time second character is coming. If we will do this one more time, so that third character will come. Okay, so like HEL in this way. So that means if you want to read the complete file or complete line that contained, so what we can do, we can do this inside the while loop. Okay, so while, so the things is we will just read the data multiple times. So every time we will read this equal to, and we will call this function. So let we will just write this here. It does not equal to EOF. So this is one character which represent as a end of file, EOF. If this is the case, what is the user definition? Okay, we have to take one variable. Okay. So this function actually will return that one character every time. But when our cursor will move to the end of the file, so special this is a special type of character which represent the end file. So EOF. So our loop will run till we get this EOF character. Okay. Inside this, we will just print our part. Okay. So this print, we can print this function. Thing is missing. This is okay. Oh, one is missing here. So now by this while loop, we will just run this. You can see complete string is now printed. Okay, character by character. So this is one function where we can that print the data or read the data. Okay, get means we are reading the data from the file character by character. Okay, and we are just getting the complete data by this way. So you can use this if required. So this is the way of to use the fgetc, and it takes a file pointer as an argument. It return the next character from the file as an integer or EOF. Okay, so it returns actually read file as an integer. So integer is just a corresponding ASCII value. What are the integer ASCII value? And we are just represent printing that data into the character specifier. So ASCII value will be printed as a character. So and EOF is just represent the end of file. It is reached. So this is one way to use, and another way is just a fget_s. Okay. So fget_s is used to read the line of the text from file, line by line. Okay, so one complete line you can read by this string. Okay, so by fget_s. So to use fget_s, you this is the syntax for this. Fget_s buffer. Okay, you have to take buffer here and define the size of buffer. Okay, what size of buffer means, just this is just a container type of thing. So in one line, what maximum size you want to read? Okay, so you can set your that buffer, that limit in the one line, what size you want to read. Okay, so you can set some size, so that size data in the one line will be read at a time, and from this file pointer. Okay, so data will be stored in this buffer, so that we can just perform this thing also. So let's use the buffer term. according to the syntax. So the file is open now, so we can take like a buffer, and suppose I'm taking 100 maximum size in the one line, okay? And let me just update this hello world. This is file handling weak. Okay, this is the one line. This is the second. Okay. So two lines are there. So let's run this code, just update this code accordingly. So this is just opening the file in the read mode, and this is the validation part. And now we will use that buffer thing. Okay. So first thing is just to, so just use the same thing. So f get okay string, and first parameter will be the that where we want to store this. So buffer, okay. And what is the size of a size? You can mention that by like 100 or something if you don't know the maximum size limit. So you can just write a size of and the variable name, and where from you are reading the data, so that fptr. So parameter, that function, and just print this by here. So, yes. Okay. So let's run this and see one complete line is printed. Okay. Now just one more time, check this. Now both line is printed. Okay. So one line is reading from the file, and we can store that complete string in one of our character array. And suppose if you set the size very small, so like 10, okay, and like 10, so only characters will be read from the file. Okay, just reload this. Hmm. So hello world, and then this. So because new line character is not received, so that means you have to just skip here. So this, and if you print this, you will get like this. Okay, hello WOR, and this is from the second line. Okay, after 10 character. So in this way, you can define the size also to read the content line by line. So this is the data, how we can read in the different way the data from the output. The next thing is same way like for the printf statement. Okay, so f printf, f put c, and f put s. So printf we have already seen. So that formatted data. Put c is the very similar to your that f get c. So this actually print a single character in the file. So this is all writing data into the file operations. So if you want to write some character into the file, so you can use this. So f put c. So f put c, you can see, is used to write a single character to a file at a time, and it takes a character and a file pointer as an argument, and it actually passes to the that print to the file. So this we can check. Now we will open the file mode, and let's check ch equal to, like suppose this is the character a. Okay, then so f put c, f put c, and we have to pass our that first parameter is just a okay. So this is like as a ch, we can pass ch and file pointer. So fptr. Okay, so that is okay, so this is not required. Okay, just run this. So see the file. You can see. Oh, okay. It's not. I think. So one character is now written into the file by this function. So if you want to write a one function at a time, so you can use this. If you want to write a multiple like complete string, okay, then you can run a same while loop. And just suppose if your is stored inside some character array, then each one by one you can read the text from the file, so text from the array, and then you uh, write into the file. So for example, suppose if you have the one string, so let's it now we will take some array, so that is suppose 100 or some 100. And now I'm assigning side like hello world. Okay. If I want to write this complete string into the that file, so we will run a loop here. So while, so what is the name of array? Ch. Okay, and we will just okay. So we have to take indexing here. So let's take index I equal to 0. That is int and I. And this is not equal to okay, not equal to and terminator character we have to pass here. So terminator character is what that is slash 0 this. Okay. So we will read our data, so we will read our data from the character array and we will pass to the this function, print in the and will pass the I. Okay, so in this way we are just reading one by character one by one and just checking while our character is not equal to the that end of the string, so this null character, and we will put into the file. So in this way we will see okay, so let's run again. Oh, something is wrong. Oh, we are not incrementing our I. Sorry. Something wrong. What we have missed? Okay, we have to replace. So previous loop was the infinite loop, so because of that, I think we got this. Okay, I think file is now also corrupted. Okay, let's remove the complete file. Let's run it. Talk to more still file is not created. Okay, so due to infinite loop things, so now data is printed for the long. So because of that, we are getting some error from the Replit. Okay, let me check online yesterday. So if anyone have any query, please ask in between. Okay. 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 So just go through the code once again. If anything, any issue is there. So we are running a character array. This is fine. And opening the file in W mode. Okay. So let me change the file name data one. Okay. So ptr equal to null printf else open. This is fine. I equal to 0. Then okay. So that I plus one. Okay. Hmm. And now this is better. What happening actually? Previous file is not opening because that we have stopped. Okay, that for our program without closing the file. Okay, because our program is stuck inside the while loop, infinite while loop, and we stopped our code in between. So that file is actually now not closed. We are not able to access again. But like this code is now working fine. Yeah, someone raised the hand. Please open your mic. Yeah, yeah, Mank.
Hello, sir.
Yes, Mank.
Sir, I have a doubt regarding qualifiers. So, in quiz one, I scored approx 36% and not qualifiers for the eligibility like 40% or something.
Okay.
And
Okay.
I am now going to give the quiz 2 on 1 December. But there will be quiz 2 for C programming or not?
No, this is not quiz two. This is so you are qualified student, now.
No, I'm not a qualifier.
Okay, you are term.
Yes,
You
sir.
have you have already qualified and entered into the program.
No,
Correct?
sir. I have to.
So that I'm asking, na, you have not qualified and you have not enrolled to
Yes,
the
sir.
course
Yes,
as
sir.
a term. Okay,
Yes, sir.
so that this is not quiz two for you. This is just a qualifier for you.
Okay.
Okay, so this quiz two is just only for the that term students, those who already entered into the program.
Okay.
Okay, but those who have not entered, those who have not qualified yet, this exam on the 1st December is just a reattempt qualifier.
Okay. This exam is same as quiz one. All the subjects with.
Qualifier exam for you.
Okay. Okay.
This
Okay,
is
sir.
the same as qualifier, and syllabus will also be remain as week 1 to week 4 only.
Same syllabus.
Yes, same syllabus, week 1 to week 4, not
Uh,
our.
Sir, it's for. Sorry, I am taking your time. Disturbing the class. Sorry.
Hmm.
This is
No,
my
no
last doubt.
problem.
Sir, week one to week four, the syllabus will be come in quiz one and quiz two. But in mails and everything, I got a news that the syllabus will be week one to week eight.
No, one thing, as I said that those using here quiz two. Okay, so for the course, because now you are entering into the week 7, 8, 9, 10 like this.
Yes,
So
sir.
those who message are actually sent to the term students.
Okay.
Qualifier student, those who have not qualified yet in the first qualifier exam on the previous date.
Yes, sir.
Now the you will be second reattempt.
Okay.
Okay, and your syllabus will be remain same week 1 to week 4 for that exam. So you have actually not enrolled in the course right till
Yes,
now.
yes, sir. I have to enroll.
Once you qualified, in the
Yes, sir.
next term you have to enroll.
Okay.
Okay, you cannot enroll in this term now. You have
Okay.
to enroll into the next term in January term. Once
January
after
term.
the qualifier, yeah,
Okay,
after
sir.
qualifier.
Okay, sir. Okay, sir. Thank you, sir.
Yeah. Okay. Okay. Fine. So yeah, we got the output file data1.txt. Data file is actually now not accessible properly because it is not closed. Okay, so these are the problems we face if we not close our file properly. So you can see we are getting the data character by character using the while loop. Okay, so this is the way we can write the data with the help of this f put c. Now the next function we have for this is fs. Okay, so this is very similar to your f get s. So at a time, one complete line you can print into the file with the help of this f put s. So, so this is also very similar to your other f print f. So that we can use this. So let's require this, and suppose use this f put s, and we can pass any string. So suppose this is a C programming course. Where is my what happened? Nothing here. Okay, the applet is out of sync. This is what happening. Let's see. Okay. Oh, set. So now my it is totally working. Let's copy this. One second. Okay, so okay, let's use this. Okay, so here we are opening the same file. So this is not now, and f put s, and then this is the first string, and then fptr. This variable is required, and then f close ptr. So let's run this, and our code is complete. And you can see in the file is created with the name of data1.txt. Okay, so this is code, this is file, and this complete line is printed into the file. So these are the main function to reading, writing into the file. So only this is the main requirement for the file handling. Once you are able to read the data from the file, and you are able to store the data in some variable array or something, then this your code become a normal problem. Okay, then perform your task perform your task similar to your previous programs, because now you got the data into your variables. Then you can do your operation. And after performing your task, if you want to write your output into the file, just use a function to write the data into the file. So this is the main actually task we should know. Okay, reading and writing, and this open the file and close the file. So this is the main thing only. After that, the your task become actually easy to your previous problems. So this concept you should know. Other thing is we have bit manipulation. Bit manipulation is also one important topic discussed, which will be used in the next course in your ES program, that is embedded C programming. So bit manipulation, we will understand that how we can perform the bit operation. So this thing we have already discussed. So this is not included in the notes. So let me open the our not one note. So bitwise operator. So bit manipulation is just a bitwise operator. How we can perform our operation on the bitwise bit data. Okay. So what are the main operators we have? We have so bitwise sorry, wise operator. So that operators actually perform the operation on the bits. Bits is 0 and 1. So this is the binary bit we have, 0 and 1. And we have discussed the binary data. So that means if we have the decimal data 10, what is the corresponding binary data for this is 1010. Okay, so corresponding binary. So you can just convert that decimal into a binary form. If you have suppose 7, so 7 corresponding binary is 0 1 1. So if we have the 4 bit representation, so we will use this. If we have 8 bit representation, so all the initial bits will remain 0 like this, and then 1 1 1. So this is just a representation for the binary representation in 8 bit form. Same 16 you can do, 2 bit you can do. Okay, so now this is the actual binary data, okay, which have only this bit 0 and 1. So how we can perform operation on this type of data with the help of bitwise operators. Okay, so this we have total main 4 operation mainly. So that first is bitwise bitwise AND, AND. Okay, the operator is just like a AND symbol. Okay, so the operator which we will use. This is called as a bitwise AND operator. And how it actually works. Okay, so how it actually works. So like as if you have done already this logical operators or logical that um, in the electronic things, logical circuits. So if you're not done, then I'll just discuss that. This AND operation is similarly work your AND operator in the C, which you use in with the two condition. Okay, suppose you have two condition like C1 and C2, and you are using this logical AND operation. So what is the meaning of this? If both condition will be true, then output will be true. Okay, suppose if this is true, then output will be true. If any of the condition is false, output will be false. Like okay, so this like true and false, then false, and then false, and then false. Okay, so here so bitwise operate this AND operator is work in the same way. Suppose we have the value of a, and this is just one bit, and this is the second bit. Okay, so this a b is the second bit. So here just consider that one is the true and zero is the false. So if we have suppose one and one, then AND operation between both will be actually uh, output will be one. Okay, AND operator. If 0 1, then output will be 0. Then 1 0, output will be 0. Then 0 0, output will be 0. Okay, AND operator. Now this operation is performing on the binary number. So we will check that how we can confirm this on the our program. So first thing, just understand that AND operator is only will provide the high input if both input is high. Okay, then output will be high, otherwise zero. Then bitwise OR operator. So bitwise operator or operator is just a single straight line. So like the second is bitwise OR operator. So this is just a straight single line. Okay, single. And logical OR operator is use this. Okay, logical OR. So this is bitwise OR. And the same things in the bit we have this logical or condition 1 condition 2. So in the or case, if any condition is true, output will be true. So same concept we will use here. So suppose this is true, 0, sorry, this is false, then true. This is false, this is true, then true. Both true, then true. And both false, then only false. So same will be used here. So okay, B and then A or B. Okay. Suppose this is 0, this is 0, then 0 only. Okay. Otherwise 0, 1, 1, 1, 0, 1, 1, 1, 1. This is the bitmap operation. Then next is bitwise XOR. Third is bitwise XOR. So bitwise XOR. Okay. So this is represented by this operator. Okay. And this we use here, suppose bit is A and B, and output A cap B, like this. Okay, this works if both inputs are different, then output will be 1. Okay, so if both are same, then output will be 0. So suppose 0 0 0. Okay, and 1 1 0. If 0 1, then 1 1 0, then 1. Okay, this is a XOR operator operation, and you will also learn this in the logical that gates course. Okay, this course. And there is one more, actually we have the bitwise not. So fourth is bitwise not. And this tilt, okay, operator is actually used to bitwise, and this is a single actually operand operator. So suppose we have 1 bit. Okay, 1 bit. If a equal to, suppose this is the 1 bit, and if we use this tilt a, so this bit will actually invert. If this is a 1, this become a so this means 1 will become a 0, 0 will become a 1. Okay, if we have like tilt 1 0 1, and we are performing this not operator, so this become a 0 1 0, like this. Okay, so these are main one more operation okay, one more we have. So this is operator basically. Two more operators are there. That is, one is left shift and another is right shift. So fifth is, yeah, this is left shift, and this is represented by double less than symbol. Okay, continuously. This is left shift, and six is right shift, and this is like this. Okay, this. So what is the use case of this? So actually, if we write like this, suppose uh, okay, suppose we have this 0 0 0 1, okay, this value, and we are writing like this 0 0 0 1, and left shift 2. So that means all bits will be shifted to the left 2 position. Okay, so that means, and this is not a circulate. If any bits is lost, it will be lost. So like this will become a 0 1 0 0 after 2 shifts. So that means this 1 is actually will be shifted here, and remaining will become 0. So this is not coming like this. Suppose if we have uh, 0 1 0 0, and we are performing 2 shift, so then this will be completely move out, okay, from this, and our data will become like a 0 0 0. Okay, all bits will be shifted to position to the left side only. Same is the reverse of the right side. Suppose we have this and we are performing three right shift, so all bits will be shifted three position to the right, so it will become a 0 0 this one and then 0. Okay, like this. So these are the basic bitwise operation we have. Now let's run this on the program and see the effect. Actually, to understand this program, we have to understand the conversion also. Otherwise, we cannot mm, understand properly. So suppose we have this int a equal to, like, that. Suppose we have 7. Okay, and int b equal to, like, we have 5. Okay, and we are performing an operation like printf and percentile c, so not c, sorry, d, and we are performing a and AND operator. Okay, so AND operator and then b. What will be the output for this? 7 and 5, we have the operation and we are performing AND logical, sorry, bitwise AND operation in between 7 and 5. So now you should know what is the corresponding binary for this 7 and 5. So let's see this. So 7 corresponding binary is 0 1 1 1. Okay, and 5 corresponding binary is 0 1 0 1. This is the binary. Just perform the AND operation in. Okay, so AND corresponding to each bit. So 1 or 1, AND will become 1. Okay, 1 and 0, because AND operator is just 0 1 if both are 1, otherwise 0. So 1 0 0, 1 1 and 1, then 0. Okay, so 0. What output we are getting? This in the bit form. And what is the corresponding the decimal value we have? Same 5. Okay, so output should become same 5 for this. You can see we are getting the 5. Let's make this as a 4. Okay, so let's make this first as a 4 and just see what are getting. 4 we are getting. Okay, we are not changing this. So 111 and let's use 3. Okay, 3 only getting. Any change is not happening. Okay. 8. So corresponding, actually what happening, the 0 value, what is the corresponding value we are getting? So that become a 0. So only the corresponding 1 value we are actually not getting high. Okay, so that's also be 8, I think. Yeah, 8. So operation is performing finally. So suppose 10 and 8. You can see 10 is 1010, 8 is 1001. So what value we will get? So you can see 0. Okay. Sorry. Now we can just look one example. 9. So in this case also we will get 8. You can see 8. Okay. Yeah. So this is actually 10. This is actually 9. So 0 1 0 and 1 0 0 0 0 0 and 1. So you can see this is corresponding to 8. Now, if we are performing OR operation in between, okay, so 1010 and 1001 OR operator. Okay, so OR operator is straight line, and 0 1 1. This is also 1. This is 0. This is 1. Okay, OR operator. What is this corresponding to? 11. So just see, if we use this OR. Okay. So what output will come? 11. You can see 11 we are getting. So operations are performing on the bit, but corresponding decimal we are getting. So we are giving input decimal value, but that is converting into a binary form, and this operation is performing on the binary bit, and corresponding decimal value we are printing. Okay, and now let's XOR also, so that this is gap. And what should be the output corresponding to this? So you can see, huh. So for this 1 0 1 0 1 0 0 1. So XOR is just a, if all input are different, then output will be high. Okay, so 1 1, then these are both same. So this is 0. So now what is the corresponding? This is 3. Okay, so corresponding output will become 3 for this 3. Okay, so these are very simple. Just you should have the good understanding of the binary to decimal, decimal to binary, and then or logical this operations and operation table and or all these tables actually. Another thing is the tilt operation. So I'm using this tilt, and suppose a, what will be the output for this? So you can see -11 we are getting. So actually, sign is just like this: 1 0 is 1 0 1 0. Now all this will be revert. Actually, initial we have all 0 bits. So if suppose this is integer, so this data is representing by 32 bits, and this is signed actually by default. This is signed. So all bits now become invert. So initial bits, first bit also will become invert. So like this, and last this 4 bit will become invert as a 0 1 0 1 like this. Okay, in this form. So this is representing actually a negative 10 value. So that's actually coming. To understand, okay, so let me take this as only 1. Then we are getting so -2. Hmm. So this is a just 32 bit because of this happening. Other, let me take this as characters. So CHAR and see what happening. Okay, same things. Character A equal to 1 bit. What it will print as it is question mark. Okay, so okay, let's see the binary form for this. Hmm. So binary form also we can print. You can see one is represented by 0 0 0 0 0 0 1. But when we are just inverting it, so all initial bits become 1, but last it 0. But corresponding decimal value is actually -2 in the representation. So this way data is now representing. Let's see. It's performing the operation like A and left shift. Sorry, like 2. Okay, so what it actually become? So you can see, sorry, 4. Okay, so we are shifting 2 times, so that means 0 0 0 1 when we 2 times, so this become a 1 0 0. So this is equivalent to 4. Okay, and let's we have the input 8 or 16. Let's this is the 8 also. Okay, so 8 is just a 1 0 0 and 0 3 times 0, and we shift like only 2 times, so it become a 2. Oh, sorry, this is right shift, so this become a 2. Okay, so these are the operation. Just remember this thing, how this bitwise operation are working on this of data. Okay, so these are only bitwise operation, and these will be used in the embedded C course with the microcontroller coding, where actually we will directly change these bits on the hardware level to perform the operation. So microcontroller actually just use the registers or memory to perform the operations, and that memory we directly change these bits. Okay, 0 to 1 or 1 to 0, just make the signal high and low like this. So we need to perform the operation to change the actually value. So at that case, this bitwise operator are actually very helpful and will be used. So just practice on this in this week. Okay. So any query in this? So reading and writing, practice with the all type of functions which we discussed. As after reading the data, just store the data and practice with the basic problems and some problems already given as assignment. We'll also discuss in the coming week as if for the practice. So I think that's it for the content today. Another, there is one more actually binary file handling that is also very similar things, but only that is not actually properly visible in your file. So because of that, but you can just look this. Only things are very small to change with the binary. If file is actually binary, okay. So opening and closing binary file. So we use this only that RB if we are opening the binary file. Previous files we consider as a text file, but this file is as a binary file. So just use this RB and WB. B is representing here binary file. Or text file previously by default is text, but you can also use RT or WT. Okay, that is represent the text. So this is the only change, but that is not properly readable to you in the file mode. Some basic operation you can see here. So write function. Okay, so this is the operation used to write the binary data into the file. F write operation. So example is given and reading the data binary data from the file. So that some operation F read actually you this is used. Okay. So you can just use these two operations to perform some binary manipulation. It's not very commonly used. Okay. So this is the content for week 10. And these first file, normal file handling and bit manipulation are more important. If anyone have any query, you can ask.
Sir, good evening, sir.
Yeah, Shiv Kumar, yeah, go ahead.
Sir, just out of the curiosity, I'm asking, sir, just in the embedded C programming, you told you will be programming the microcontrollers and stuff. So, how would be the architecture, sir? Because now we do program in the computer, we have a compiler, all these things loaded. How the microcontrollers, the compilers, and other things will be there? Overall architecture, if you have something to show us.
So that architectures, all these things we will discuss in the course. So how the architectures are actually used in the microcontroller. For the programming, actually, generally we are using the one STM microcontroller.
Ah,
Okay, that microcontroller we are using
hmm,
in the course, and we have
okay,
one online simulator for that. That is name is WalkV.
okay,
That WalkV is provided that controller coding for the STM board or as well as the another board also. Okay, so that Arduino board also.
okay,
So otherwise, physically we also demonstrate in the live session some board we have,
okay,
and in that session we that demonstrate the physical board also during the code. That
okay, sir.
company actually STM company also provide their IDE actually. Okay, so
Okay,
through that IDE we write the code. We actually that debugging the code, all these things we perform. We can perform through that IDE, and after the writing the code, we upload the code on the microcontroller.
okay, sir.
Okay, and
Okay,
then that code actually runs the microcontroller and perform the task.
sure, sir.
So in that way, we actually write the microcontroller coding. And
Okay,
later, once the course is completed, then lab is also there. Physical lab is also there. So that lab also, that physical demo actually will be provided.
okay, sir. Sure, sir.
Hmm.
Thank you, sir.
Okay. Yeah. So many students are trying to join the class, but for 7:20. No, nobody is joining. I think.
Yes, sir, I am trying since 6:30.
Ah. Okay. So actually, I've enabled this automatic joining. Those who have the ITM email ID, but I'm not sure this is not working. I think, but okay, no problem. If you have any query, you can ask. Otherwise, you can see the okay.
Okay, sir. But sir, CT does not updated, sir, where the all sessions link are pasted, sir,
Okay.
in
Otherwise,
dashboard.
so what happened actually? Once you open any YouTube link, okay, then after that you can just go to the playlist or go to the just live session live on that channel. Okay. Suppose let me open the link for this. Let me share this. Just I'm copying this YouTube link coding. A seat. Okay, I'll update that seat also today. You can see this is the current live recording. Okay, once you reached at this of any recording point, just go to this channel, Introduction to C Programming CS, and just open this live. Okay, you will get all the live session which already done in this course right now. Okay, if any course you can see Beak 9 PPA, Beak 9 practice, all live sessions link are there. You can directly reach. Okay, if you don't have the seed data, so in this way otherwise playlist also there, so you can also see the previous terms live session if you want. Otherwise the current term sessions are inside this playlist, or if any that session is not in this playlist, you can see directly inside the live here. Okay, I'll update that sheet also, no problem.
Okay, sir.
Hmm. Okay, so if there is no query, then we can wind up the session and just keep joining all the session OPP, mainly OPP session. Okay, so do not skip the OPP session. Just practice with the OPP session for the programming, and just try to clear and achieve get the maximum marks in the OPP exam.
Sir, OPP is on 7th or 8th, sir?
I think this is. I have to check actually. This is seventh, not seventh, eighth, I think.
Okay, sir.
Okay, but only one date is there, 8. That is
Okay.
the.
Last time it was Saturday, I believe, sir. Last time OPP one was
So
Saturday.
I think this time it is, I think, on Sunday.
Okay, sir. That's what I want to clarify.
Otherwise, you will get the notification also for the final
Yeah.
date. So,
That's,
okay.
thank you, sir.
Okay, then. Thanks, everyone. Bye.
Thank you.
Thank you, sir.
Okay. Bye.
Good night, all.
Yeah. Good night.